First of all, I want to thank you to agree to this little interview, and the idea is to ask you questions about the general things. And I think we will start with an easy one.
They get difficult after that.
Tell us if you were, like, when you start to do chemistry and do a degree, you were believing that it was your real vocation, it was a call for you, or it was something that you did at that time and you didn't know if it was going to be a...
I didn't know. In fact, I was interested at the beginning in philosophy. I wanted to study philosophy at the university. I started already before end of high school to read philosophers. But then in France, at that time, you had to have at least one science exam for studying philosophy. So I started with science, because I thought, okay, if I don't like philosophy, I can always continue in science. And then I became very interested in chemistry. One reason was that philosophy is, of course, very exciting, big problems, but you have no way to check the problems. Whereas if you do science, science is based on checking, on facts. So I was very interested in doing science, and especially chemistry, because chemistry had one thing, like many of us, many people have become chemists, they do some experiments at home, in the kitchen of their parents or things like that. And then I was very impressed by the fact that in chemistry you can transform compounds into one another. You can do chemical reactions to make new things. And this was very exciting. The fact that you mix two things and you get something else, and you can even usually know what is going to happen, not always, of course. So I think this possibility, this power of chemistry to create new objects, new combinations of matter, was very exciting for me. And then I had a very good teacher, professor at the University of Strasbourg on chemistry, Guy Ourisson was his name. And so I continued chemistry and did my PhD with him.
So I think that a question here now would be, so how important do you think that teaching is, not only also in high school, apart from the university, also in high school?
Oh, teaching is very important, but you have to have, teaching is important to raise your interests. But basis of the work is something which you have to do yourself then. But the teacher has to be acting on your curiosity, to make you think about interesting problems.
Had to be the catalyst.
It has to be a catalyst, yes, for absolutely, yes, a catalyst for being interested, and not necessarily giving you the best lectures. I think, of course, good lectures are always very exciting, but if you work by yourself, and I think I would recommend that, following courses is important. But then you have to go home and sort of rethink the courses and take books and read and so on. Not just say, oh, we had a course and now that is what we need to know. No. You need to know much more than the course. The course is 1 hour. So there are many other things. And you have to work by yourself. And that gets you also interested, that gets you motivated.
You will do it again, chemistry, or you will select other subject? And what will be your advice to, now we have here the students making these exams to go to the university. What will be your advice to them to select what they have to choose for degree, let's say?
What they have to choose is what they are interested in. Because, it's your interest. You are making your life, so it's your business. It's not the professor is important, but it's also these people students, when they enter university, have to realize that you are making your life. It's not just being there to be happy, to have good notes with the professor or good marks. That is just a secondary thing. This is to get a diploma, your piece of paper with signatures. But you have to be interested.
I think that in the same way, they always put a lot of pressure in. You have to choose the right thing, and then you cannot change. It's like change is forbidden from the.
No. Change should happen all the time when you get interested in something. But this is now a tendency to be more open to change over the years, and this is also something which I think is a good personal education to change either topics or place or people, and diversity is very important. Being stuck in one dimension, this is no good. One has to be multi-dimensional, or at least try to be.
And coming back again to advice, and now related with the research, when guys like Ferran start to make his career, how do you differentiate and select between, the fashion of the moment and the things that they are going to be good for your career, good for your development? What will be your advice to people like Ferran that is starting now to make the postdoc and to make his career?
Yeah, that's a very difficult question, because all of us, we are already always faced with this question. Not just at the beginning, but when you have a laboratory, you have to ask yourself what we are doing. Is it worth doing? Is it worth spending your time on it, or asking young people to spend their time on this topic? That's a very hard question, and it's a responsibility. But I would say that now there's a pressure on getting papers. Okay, so you have to take that into account. It's true that if you want to have a career, you have to show that you can do things. You have to have the ways which nowadays one counts the activities to look at the papers. But this is only the appearance. This is not the most important. The most important is really to try to find something which is original, which is new. And since all of us have had a different education, we can make combinations which are very different. It's not the same. So since you asked this question, when I'm asked this question very often, what to do, how do you do? So I have 3 advices, but there are many more. One of them, the first one is, don't miss the train. I mean by that, if you work in some things, and often there are effects, there are results which you did not predict, which are there. So some people are unhappy with these things unpredicted, and they throw it out. But often this is more important than what we're looking for. The other one is, don't jump on a train which is already full. That is what I was mentioning earlier, that there are fashions. Fashions have an advantage. If it's a good fashion, you get a lot of citations. You get a good CV. But it's not very original in many cases. So try to find something where there are not so many people working, but which is very promising. It's usually more difficult, but I would say you should combine the two. Some to get papers because you need it for your career, until, of course, the administrations change and don't count papers, but look at really what is inside. And we talked about this yesterday evening, the fact that it's good when you want to, and very important in a university, to hire new people, to get new professors. In fact, that's the most important thing, is to talk with the people, not just to look at CVs. Okay, you have to make a selection, so start with have CV. But there are some CVs where I could cite, of course, in the past, very famous chemists to have very few papers. Very few papers. For instance, the total synthesis of vitamin B12, that's one of the biggest achievements in organic synthesis, in making vitamin B12 from the elements, will never be published, really, because people have disappeared, and this was a long time ago, and in fact, it's quite incredible, but it will not be published as such, as a full story, whereas it usually, it has involved many, many reactions, many, many people contributing. two groups collaborating transatlantic between Switzerland and the US and Massachusetts. So I think one has to have some research which produces, but then something else which is much longer range and which is done, if it works, really a breakthrough.
And how important are collaborations during the research? So now we are in an disciplinary world.
I think, first of all, I've always considered, as long as I'm a PhD student or a postdoc, I work with somebody, and that person has to teach me things, and I do work for them. I think this is quite clear. If you are a student, you want to learn. The teacher has to realize, the teacher or the principal investigator, as they are called today, they select the problems, and they have to feel the responsibility of that. But at the same time, they may have ideas which work or do not work. But I always found that during my PhD and during my postdoc, I was learning. Then you build up your ground, your basis, and after that, you develop yourself.
And you were speaking about trains. So what do you think are the trains that are going to change the field of chemistry in the near future? For instance, there's a lot of people speaking about this IE, artificial intelligence.
But this is now a sort of word which everybody uses, and it's important, of course, for many fields, not just chemistry. What troubles me with AI is many people look at it as a black box. You feed things in, and the computer tries to manipulate that, and you get something out, but you don't know why. So it's a sort of a black box approach. And in fact, I talked about this with a mathematician not long ago, and I find that very unsatisfactory. Because if it happens that something comes out of a bunch of things, there is a reason. If you add something, and in fact, you can probably investigate it by simplifying the system. You make it first, let's say suppose you look at the shape of a molecule, but you don't know how a given molecule, you don't know its shape. Then you put in all molecules which are resembling that one, of which one knows a shape, and then ask the computer to deduce a shape for this unknown one. Okay, this is, you put in data, so you can have an approach where you progressively add the data and try to see how it leads to the final result. So I think AI is very powerful, no doubt. One can just be happy with the output, okay? But in order to really bring something to science, you should try to understand why this output is produced. So that's one thing. Then the collaborations between fields, or let's say interdisciplinary areas, are very important, because often it's at the interface between different topics where new things can appear, and where you also can make original combinations between two fields or three fields, between a given topic. We have talked this morning, for instance, about drug release. Now, drug release, that the molecule is important, the physical chemistry of the object is important, the drug you want to release is important, the finding out the selectivity of the drug, the action on a given organ and not on other ones. So, and these are all different fields. And of course, at the end of the game, you have the medical person who has to administer, and this is again something you have to work in close collaboration. So there are many areas like that where different fields come together: chemistry, physics, biology. Chemistry has a very interesting feature, which is a central science. It touches physics, material science, it touches biology, biosciences. So, and it touches also its own field, is to construct chemical objects. There's something people don't realize, that chemists are always making, and that is one of the very attractive things of chemistry, objects which did not exist yet. Huh? Everybody tells you about nature. Okay, nature is producing lots of things, but there are a lot of things nature has not produced, and chemists can do it. So chemistry is a bit like art. It's making objects which don't exist yet. An artist wants to do something which nobody else has done. And much of chemistry is also this.
And what do you think about the society that thinks that chemistry, so they sell products and they say, oh, this is free of chemistry. So they have like a negative idea about chemistry.
First of all, we are all chemistry. Our organism is chemistry. Of course, it's much more complex than simple reactions. But a living organism is a very complex set of chemical processes, chemical objects, which are built together in a chemical way, and which then undergo changes, reactions in our body and so on. So we are a very complex chemical object. And I guess some people don't like that, but you cannot avoid it. We are a bunch of molecules, but very, very complex one. You know, in order to make people understand a little bit that complexity can come out progressively. And now this is this philosophical view also of emergence, emerging new properties. What in general public lectures, what I take as example is really the simplest. One molecule of water has 3 atoms. I now talk also for those who have never heard about a molecule of water. H, OH, like a triangle. When it is vapor in the gas phase, isolated, it cannot boil, it cannot freeze. It has no refractive index, it has no viscosity. You take a glass of water, it's still water, just water, but it's a glass of water. So now the molecules interact. So new properties appear. A glass of water can freeze. A glass of water can boil. A glass of water has a viscosity. A glass of water has a refractive index. A glass of water can be used to dissolve things in it. You see, these are new properties which appear just because you have a glass of water, a population. I think one can even say, I like often to say that especially the molecules, the supramolecular chemistry, where molecules get together, is a sort of molecular sociology. Yeah? Yeah. How do molecules behave when they are together? Of course, if they are all identical like water, they have a much more complex behavior than the isolated molecule. But nevertheless, it is a big jump in properties. Going from just an isolated to a glass, it's incredible, the jump. All these new properties which appear. And if you then think, okay, that's the beginning. If you now think that you add other things to that, then it gets more and more complex, more and more different kinds of properties can appear. And then, okay, it gets much more complicated to talk about. But I think this possibility of getting new properties by mixing things, this diversity in features, it sort of shows how complexity can come out of simple things.
So I think we have to close because we have to go to your lecture, and it will be not nice that you will arrive late. So thank you for agree for this little interview and for your...
I would like to thank you for the invitation to come here. We had very interesting discussion this morning, and I appreciate the discussions which we had. I think you have a small group, but I think very active group.
Thank you very much.
Very happy to have this discussion.